name is Brad Newberg. Today I want to be talking to you about HTML5 and giving you an introduction to interesting aspects of the new standard. I'm with Google's developer programs, specifically a group called Open Web Advocacy. Our group is focused on helping to do outreach, education, JavaScript toolkits that help really increase the rate at which developers can use interesting new web technologies like HTML5, SVG, CSS3, and more. Before jumping into HTML5, I want to set the context of where we are on the web today. The last 2 years, we've really seen the web platform accelerate. In this graph, you see at the bottom sort of the web capabilities. And at the top, you see the capabilities of native applications, which have stayed roughly the same the last few years. What's really interesting is the last 2 years, we've seen an acceleration of what you can do on the web that's starting to get close to the abilities of native applications. We see the iPhone was a real game changer. Safari 4 really increased capabilities. Opera has always been a leader. The Android device really opened things up, and so on with the introduction of Chrome, Firefox 3.5. And we see that over time, the web is getting better and better and better at having a greater degree of fidelity of things that you want to do on the web. And what's really unique is that as the web the last few years has really accelerated with modern browsers, it's solving real developer challenges. And when we get into HTML5, we'll see how some of these solutions play into these challenges, but things like having improved graphic support in the base platform of the web, being able to tie location into your web applications. Storage means actually being able to use the abilities of a desktop machine to do storage so that we can treat it as more than like a Commodore 64. We have these very powerful machines. Let's start using them on the web. And finally, speed. That's been a really key change. JavaScript has gotten much faster, and that's a game changer. Along with this has been something that's really surprising. You know, when Firefox really helped create the idea of a consumer-driven open source application, that was a new untested idea. People didn't know could open source scale into the consumer market. Well, I think at this point, that's a done experiment. We know that it's true, that it can happen. If you look at this, you'll see that there's an increasing, accelerating number of developers contributing to open source projects, to open source web browsers, including Chrome, Firefox, WebKit. So that's really going to help accelerate even more what we have. And at the same time, you see a roughly linear trend in terms of the number of users. Here we see millions of open source browser users that is increasing over time. At the same time, sort of setting the context of where we are today, we see a tremendous improvement in JavaScript performance. And we are only at the beginning of that trend. The last 2 years, we've begun to see that. We've already seen a roughly 100x improvement in JavaScript performance, really pretty much within about the last sort of year and a half. We're only at the beginning of the optimizations that are possible when you treat JavaScript as something that you can really crank a lot of performance out of. So these trends come together. You know, the increasing fidelity of web applications, a greater number of open source browsers, faster JavaScript. These come together to really kind of create the stage at which HTML5 can really do much more than HTML4, which was the last major iteration of HTML, which was really in the late 90s. So it's really time for a new version of HTML because we are in a different world at this point than we were then. And this time around, I just want to sort of make a point that let's do it differently. One of the really surprising things is most people don't realize that Ajax, the idea was invented by Microsoft in the late 90s. Outlook Web Express in 1997 was the first app to use Ajax, which at that time was the XML HTTP request object. And it really took until about 2005 for Firefox to also support that in the other browsers, and people to sort of wake up to the fact that, hey, you can combine server background server talking to support with things like more advanced CSS, HTML, and that kind of gave us the world that we have today. But it took something like 8 years to really gain enough awareness and gain enough support for people to really start paying attention. You know, this time around, I think people are going to notice a lot sooner the capabilities of HTML5 the capabilities of SVG, CSS3, faster JavaScript. Let's not wait as long as we did then to start really doing amazing things. And I think we're actually going to see that shift. So people are already jumping on these things. So let's do things differently this time around. So the structure of the talk I'm going to do today is I'm going to talk about 5 major sections. I'm going to talk about vector graphics on the web, including Canvas and SVG, Scalable Vector Graphics. I'm going to talk about video within the HTML5 standard. I'll talk about geolocation. I'll talk about the application cache and the database. And then I'll talk about web workers. The HTML5 spec includes more than this. These are 5 aspects of the spec that are very exciting and very useful. We could spend a whole day talking about these aspects. There's so many interesting things in there, including new tags, sort of cleaning up, describing how you render older content, and so on. We're going to focus on these aspects today. Each one of the sections, I'm going to give you an introduction. I'm going to give you some sample code and some demos, and I'll sort of talk about how this fits into what you're doing. So let's get started. Let's jump into vector graphics. So until recently, you really couldn't draw on the web. The web itself didn't really provide primitives to help you actually draw things on the screen. And the graphics, if you could, kind of get some graphics out there, they weren't very interactive. They didn't interface very well with JavaScript. Now, you could sort of rely on other sort of aspects of the web to do this, things like Flash, Silverlight, VML, which was an early vector graphics language from Microsoft. So a lot of people would sort of do clever tricks in order to do some drawing on the web. But what's really cool is if we can get graphics to be an intrinsic part of the web, what you get is things interact really well with each other. And that's what's so cool about Canvas and SVG, which I'll talk about both of them, is they embed themselves into the web platform. They're a part of HTML. They're a part of the document object model. They can fit into CSS and HTTP. And that gets really powerful. As you'll see, that lets them break out of the box and do really cool stuff using existing web skills. So let's talk about both. Let's jump into SVG. So SVG is an acronym that stands for Scalable Vector Graphics. Really, they just give you new HTML-like tags for drawing. So to do a rectangle, you get a rectangle tag. You can say where on the screen to put it. Here we're putting it at x equals 0, y equals 0. You can set a width and a height. You can add a fill and a stroke. There we're changing the width. You know how many crazy hacks people have done to do rounded corners? Well, it's really easy with SVG. There we are making some rounded corners. We say round the x side, round the y side by 8. Boom. One line for rounded corners. That's nice. And then finally, I talked about how this stuff is native to the web stack. So we can add an ID that will allow JavaScript to grab this. We can add a CSS class, which lets you style this with CSS if you want to control in a centralized way how aspects of your drawing are displayed. And right there is what that particular tag would get rendered as, a blue square with some rounded corners and red outline. Now, what you just saw surround this is at the very top, that is the HTML5 doc type. That's the thing that you drop at the top of your page, and that tells the browser, hey, this is HTML5. Now, SVG is a web standard that predates HTML5. One of the things that's really unique about HTML5 is it now says, here's how you drop SVG right into a normal HTML page. So it really makes SVG a core part of HTML. So right here we see we've got some normal HTML. You say SVG, and then you drop your markup in. So that's one of the really cool new aspects of HTML5 that hasn't got as much attention as it should because it's something that's really unique. We now have HTML-like tags that do drawing right inside of HTML. Now I mentioned that one of the unique things about these things is they integrate well. So these aren't just static graphics. These are graphics that you can animate, you can interact with. Here we are using the normal document object model. We grab our rectangle. We can use sort of the exact same way that we change the style of HTML. There we are changing the fill to green. We can add interactivity, again, the same way. There we are doing an on-click. So when you click on the rectangle, it says hello. And that's it. Interactivity is really straightforward. This shows sort of one of the nice benefits of what it means to have scalable graphics. On the left, you see a normal bitmap. When we change the size, it distorts, it pixelates. On the right, whether you're looking at an SVG image on a 40-inch monitor or a small iPhone screen which supports SVG, it still stays beautiful and legible. That's one of the benefits of this technology. So let's jump into the Canvas API. The Canvas API I like to think of it as a scriptable image tag. As opposed to SVG, which is markup, it's a tree inside of your HTML. The Canvas API is more like an image tag that you can create JavaScript that directly scripts and draws your own custom image. So the first thing you do to use the Canvas tag is you drop a simple tag that says Canvas into your page, give it a width and height, and you give it an ID. Then your JavaScript grabs that Canvas tag and gets what's known as the context. So we get a context, which is a drawing surface area. Right here we say a 2D context. This is really interesting. It opens up the door to say 3D in the future, so you could possibly do a 3D drawing context. We just saw something called WebGL, which landed in Firefox 3.6 recently, which is a 3D Canvas API based on OpenGL. And that's really exciting work. That stuff is not formally a part of HTML5, but it's experimental, interesting things that's happening out on the edges that's starting to gain traction. Once you've got your context, you can set the fill style. Here we are saying make anything that we're going to draw, fill it as red. Here we are drawing a rectangle. That's the X, the Y, the width, and the height. Here we are adding opacity. So we say RGBA. That's going to make a 50% shaded blue rectangle. There we are drawing the rectangle. And there you go. There on the right you see the two things that we just drew. You see a red rectangle with the partially opaque blue rectangle on top. So I want to show you some demos. A lot of people ask, how do SVG and Canvas fit together? Well, what's interesting is they both fulfill different use cases. I will touch on that, but I want to show you something really unique, a really great way that they integrate together. This is the Mozilla Firefox download page. What you see on this page, you see a map of the world. That map is drawn using SVG, it's markup. And then you'll see occasionally a little yellow dot show up in a specific location. Those are drawn with Canvas. This page keeps a connection open to the server so that it has streaming events, and it records whenever anyone downloads Firefox 3.5, where in the world are they downloading them. The thing I love about this page is it really shows when to use either technology and when it's appropriate. SVG is great when you've got graphical assets like a map of the world or maps in general or a drawing of a tiger, for example. That's a really appropriate thing, and you can bring that in. Canvas is really good when you want to add drawings on top. SVG is good for interactivity, so you can play these things together in order to use their strengths where appropriate. This is a really cool demo of Canvas. Everyone's played Doom. This is not a first-person player, it's a first-person gifter as we walk around. So this entire thing is drawn with Canvas, and you can't see, but I'm using my keyboard to walk around. Again, this is a really good use case that shows Canvas. It doesn't have mouse interactivity. Canvas is really good if you want to create games that are keyboard driven. SVG is good if you want to create interactive mouse driven things. So Canvas is great for creating a side-scrolling game, for example. This is an interesting population demo. Over here we see sort of demographic information showing the sort of the number of men and women in Germany. Now this right here is SVG. This is normal HTML. This shows them integrated together. The SVG is right in the page using HTML5. What's really cool is what makes this, and you see as we run over, this is just using JavaScript that adds itself, just like you saw with the samples on mouse over, to show further information there going in. What's interesting that makes this unique is in real time we can change the language of the image. So if you were to push down a static image, you couldn't dynamically change the language of the page and the data. And you also couldn't do the interactivity. So this shows one of the strengths of SVG. You can think of them as information-dense data that you can push down. Those are really a unique way to use SVG. Another great example of Canvas is Bespin. This is a graphical developer's editor created from Mozilla that allows you to do all sorts of interesting collaboration, social sharing right within. The whole thing does all of its drawing through Bespin. It's a really, really cool use case. And finally, I want to show you one last demo of these two technologies. This is an atlas that shows all of the results of the German election. It's information dense. We can drag it around. We can zoom in. Again, on the right here is HTML. On the left here is SVG that's natively integrated. Of course, as we go over it, we can update what's going on in the HTML. We can break this down by different political parties. So there you go. You get kind of a sense of both technologies. So a really natural question is when Canvas or SVG? When should you use one or the other? So SVG is actually what's known as a retained mode API. In graphics, you have retained mode APIs and immediate mode APIs. And you need both for different situations. SVG is higher level. You want to use it when you need import and export, like I said, of graphical assets. You can load it into Illustrator, into Inkscape. Whenever you want to create easy user interfaces, because SVG is a retained mode API, that means there's a tree of everything that you've added to the screen. So it's really easy to do hit detection and adding events to things because you can just add your listeners somewhere in the tree. It's interactive, it's good for medium animation, and it gives you a tree of objects. So when should you use Canvas? Well, Canvas is lower level. And depending on your project, that's a strength or a weakness. It's really good when you don't need that tree. When you don't have mouse interaction, when you have just keyboard interaction like with a game. When you have a tremendous amount of high animation, especially if it's not interactive, Canvas is a really good choice because that tree just gets in your way. You don't need collision detection. It's JavaScript centric. It requires some more bookkeeping in order to do what you need to do, but that can be a strength depending on your application, and it's really pixel oriented. So really, depending on your application, you need to ask yourself, what am I trying to do? And you need to use the right one. If you have something that's sort of markup oriented, that needs to be interactive, and you end up using it on Canvas, you're going to rebuild a lot of infrastructure that SVG gives you, and vice versa. If you try to do 1,000 bouncing balls that aren't interactive or a side-scrolling game with SVG, you're going to fail. So choose the right one. We need both. So where is this supported? Well, both Canvas and SVG have excellent support across all of the modern open source browsers. And something that's really cool I want to briefly touch on, over at Google we're working with others in the open source community to create a drop-in JavaScript library called SVG Web that brings SVG to Internet Explorer so that you can now deploy SVG to close to 100% of the installed base. I want to play a very short video that sort of shows you SVG Web. It's 1 minute. I just want to mention, actually in just about 2 weeks, the SVG Open Conference will be talking more about SVG Web. We're working with Wikipedia. They're doing some very cool SVG work. They'll also be using SVG Web Toolkit to have these images work on IE. And so keep this in your radar. Some interesting things. We're doing some interesting things there. So let's talk about HTML5 video. So currently video is complicated and it's outside your control. So at this point, I like to say in 2009, video really should be a part of the browser. You know, multimedia is obviously here to stay on the web. It's an integral part. It needs to be a part of the basic web platform at this point. What's so cool is that HTML5 now gives you a video tag that really works very similar to the image tag. You don't have to have really complicated objects or plugins. Video just works. So let's look at some example markup of what that looks like. So you have a new video tag, and there you point to your video file. And you can add attributes. There we've added the controls attribute, which will cause the browser to give a nice little sort of control bar with play and stop. You can drop fallback content on the inside if that browser doesn't support the video tag. Now what's really interesting is, oh, 1 second. Technical difficulty. The lights went out in this room. What's really interesting is the different browsers that support HTML5 video support different codecs. So at this time, you generally need to provide an OGG version and what's called an H.264 version, and that's straightforward. You just drop in what are called 2 different source files, and you can give the type. What's really cool is that, again, this stuff is a native part of the browser. To script it, it's really straightforward. There we are grabbing the video tag from the page and playing it. And there's a whole host of APIs around video. You can have callbacks when different events happen. You can draw onto the video element in order to add your own custom interactivity. You can do all sorts of cool stuff. And I will show you some of that. This shows right there, you see there's the browser control that it added.
For years, Billy's been trying
This is
to
an OGG
customize his web browser.
video
This'll make it go faster.
showing a Firefox promotional video that's in OGG using the video tag. Now what's really cool, as I said, this stuff jumps outside the box.
Gave up on his dream of a better browser.
So as it's playing, we can use
Then he discovered
JavaScript to
Firefox,
rotate
secure,
and
easy to
change
use, and customizable.
what's going on.
Firefox is Billy's web browser of choice.
That's what's cool when things are a part of the browser. This is a mock-up of YouTube using the video tag, the HTML5 video tag. Now what's cool is right here, this is HTML5 video. It's not any other plugins. And each of these little thumbnails is the HTML5 video tag as well. And what's cool is they just have some little JavaScript on them that say on mouse over, play, like you saw, on mouse out, stop. So we have some small thumbnails. And I actually like to crack open this page because I think it's a great example of a lot of different HTML5 things going on. So let's look at the source of this page. At the top we see the HTML5 doc type. We see the HTML5 header tag. This actually allows you to define a header, sort of something at the top of your page. Here we are just sort of saying what the page is. We've got the new HTML5 nav element. This says that the following things are navigation. Let's here we fill that out. And then we've got the HTML5 article tag. The article tag says that here is where the real content of the page starts. So that helps search engines. That can help anyone who wants to script a page and sort of understand it. So the article tag surrounds where the real content is. And then the header, the nav, that allows you to say, oh, that's the Chrome of the page. Within an article, you can have various sections. So here's the HTML5 section tag. So our main video on the page is one section. Our list of thumbnails is another section. Here we are, we see the HTML5 progress tag. That allows you to show as you're loading something how much is loaded. Here's the meter tag. So that helps with the common use case of having little stars to rate something. We see all over the web, so that's a way to actually do that with less scripting and less custom code. And let's find one of these video tags. Here's one of our thumbnails. So AutoBuffer says, hey, start loading this in the background, even if we don't play it. That's going to make the performance better when you run the mouse over. Loop says, just keep playing this over and over and over in a loop. There we are providing the source. And so on. So this is, I just like this page. They're just using a lot of different HTML5 elements. It's a good showcase. And then I think they use the footer tag as well at the bottom. So just like the header tag, the footer tag is where you can put copyright information, other aspects of things that aren't part of the article. So the video tag is well supported. It shows up in Chrome, in Firefox 3.5. It's in Chrome. It starts in Safari 4. It's in Opera. The one thing right now is there's essentially two codecs. That's what's one known as the OGG, sort of Vorbis codec, and then there's H.264. At this time, the safest thing is just produce both videos in both formats. There's open tools that can easily do that. It's a pretty straightforward process. So let's look at geolocation. So geolocation, this is one of the things I'm really excited about. On this page, you see all sorts of things that are possible once you have geolocation. You can do CRM systems. Social applications become really, really interesting with location. Ads, of course. Games. People haven't really tapped into that one yet. That one's going to be really amazing, especially when you combine augmented reality, photos, and so on. Now, what's interesting is most of the HTML5 geolocation backends don't just use GPS and don't just use IP. They also tend to try to grab the cell ID and the Wi-Fi to bring in more data. So having all three of these, you only need one really to get location. They help you kind of trade off different design constraints to get the location. But that actually happens in the background. You don't have to be as concerned about that. So what's really cool is we now finally have browsers that are location enabled. The latest rev of the iPhone OS has geolocation, Firefox does, and so on. It's now in enough places to do some really cool stuff. So let's look at the API. I love this API. It's so straightforward. You get a new object called geolocation that lives on the navigator object, and you call getCurrentPosition, and you give it a callback that will receive the location when it's ready, and you get a position object. And this object is really straightforward. You can grab the coordinates. There we grab the latitude. We grab the longitude. And then you can pass that to some method that can do something with that. Here we have a show location method that might show it on a map, for example. Now what's really cool is there's actually lots of other things on here. You can find out, what's the degree of reliability of that, sort of what's the resolution. So you could draw a circle depending on how well you know that location and so on. But the basic use is really straightforward. I want to show you a prototype of Google Maps that uses this API. Here at the top, here's how we see how it becomes secure. No website obviously should be able to read your location unless you give permission. So it says, hey, this website wants to show your location. You can give permission or not, and you can remember it. It thinks a little while, and boom, it figures out where I am, and that is where I am. I'm downtown in San Francisco right now. So where is this supported? It's in all the browsers. For Safari, it's on the iPhone currently, but it's not yet on Safari Desktop. Now let's look at the app cache in the database. So web apps, if we really want to keep them evolving, they really need to be able to work everywhere. You don't want to use your web-based word processor or web-based address book only when you have a network connection. It's important to be able to use it on airplanes, when you have a spotty internet connection, perhaps you're overseas. Maybe you're in a dead zone where there's no Wi-Fi or cellular connection. So when you really critically need your web app, it needs to be available. The HTML5 database and app cache work together to help provide offline web access. So before I show you the code, I want to show you a cool demo of both of these together. Here's some old messages actually that were already saved. We can add messages, we can make new notes, we can delete notes, and then if we quit the browser and come back, we will see our latest data. And that is all being saved into the local database. So let's look at this. So the first aspect is what's known as the application cache. This is what I like to call, it's a super browser cache. We can't depend on the browser cache to have everything we need for our web application for a number of reasons. One, things may have timed out, and there may not be stuff in there that we need. Maybe the user never went to some aspect of an application, but you still want to go to it when you're offline. So the application cache, think of it as a super browser cache that you control as the application writer. And it's really straightforward to use. The first thing is you create a special file where the first line says cache manifest, and then you provide all of the resources, the HTML, the CSS, the images that you want to take offline. And here we have all the things for that sticky notes demo you saw. Then in your HTML, on the body tag, you add a new attribute. You say manifest equals, and then you point to your cache manifest. The one other thing that's not shown here is on your web server, you make sure to have the cache manifest have a certain MIME type that's unique, that's for this offline app cache manifest. And that's it. That's really straightforward. At that point, when the browser first sees this, it will take those resources, bring them locally, and then automatically in the background periodically see if they've updated to pull down the fresh version. And now they're available for the user to actually see your user interface because the files are available locally. So let's look at the database. That's the other major aspect of the HTML5 offline abilities. What's really cool is this is a real relational database, so you can do some cool stuff with it. To use, the first thing is you open a database. So here we see you give a database a name, you give it a version so that you can know what version you're working with if you need to migrate data. You give it a title. Here we say example database. This would be shown to a user if in Safari 4, for example, a user can go and pull up a list of all their databases through the preferences or through the developer tools, and then you provide an estimated size at the very beginning of how big your database is, and here we say 200K. When that happens, by the way, the first time a user will be prompted, do you want to allow this website to store up to 200K of data, and they'll give permission or not. Then let's look at an example sort of save me method. Here we are, we're taking sort of everything we need to save one of these notes. So we take an ID, some text, a timestamp of when it was made, where it is on the screen, and a z-index of how it's stacked. So the first thing is once you've opened your database, you get a database object, you need to do everything as a transaction. And you call db.transaction, and you give it a callback function that will be called when the transaction is ready to go. The reason you need to do this is because the web is a very unforgiving environment. Users could quit your application right in the middle. They could crash their browser. This is a tougher environment than a traditional desktop application. If you put everything into a transaction, you're already set up to make things more reliable. Once you're inside the transaction, then you can actually execute SQL by calling the execute SQL method. And you provide normal SQL. Here we are, we're saying insert into a table called WebKit sticky notes that we made. There's the columns, and then we provide the values. You provide all your values where you want them to plug in, you put a question mark, and then you provide an array that will fill in any of the new values. And there we go. One of the other things I should mention is not only are the transactions asynchronous in order to help in a more unforgiving environment, it also helps performance. It means that the browser can execute the SQL away from the user interface thread to keep things from locking up and really give a better experience. And this one is in all the modern open source browsers. It's currently only on Opera Mobile. It's not on the desktop edition yet. Now, web workers. So sort of using all this JavaScript is kind of a double-edged sword, right? We can do more, but that also means we can end up not writing apps great that end up sort of freezing the browser, causing it to run slowly. If you have a lot of JavaScript, JavaScript runs in the same thread as the user interface of the browser, so as it's sitting there running, the browser won't respond to the user clicking around or if they want to go to another tab. So as things get more powerful, we can end up hosing the browser. So what's really cool is HTML5 gives you something called web workers, and this lets you run JavaScript in the background in such a way that it won't hose or kill the browser. I want to show you an example that really illustrates this. Nothing really shows us more than trying to find prime numbers. The field of cryptography is really based on the fact that prime numbers are hard and computationally intensive. I want to show you a sample that tries to find prime numbers using traditional JavaScript without web workers. We click go, and you'll see that the browser is totally locked up. Matter of fact, it doesn't even report a prime number yet. It's still working. Things are bad. And I literally have to kill the browser. That's bad. We don't want to do that. Let's look at good primes. This is using the HTML5 Web Workers API. We click go, and we see primes coming in. Things are still responsive. We can still interact with the browser, and it's very fast and responsive. Very cool. Now, all these pieces come together. Again, that's what's so cool. You're going to see these things don't just live in a box. I want to show you a really cool sample that brings together HTML5 video and the canvas tag and web workers to do something that literally a year ago, if you had asked me, would people do this on the web, I'd say, you're crazy. But someone did it on the web and it works well. Okay, so what you're looking at here is I'm going to play some video, and JavaScript running on a web worker is going to get the pixels from the HTML5 video, process where people are moving, and then use the canvas tag to draw bounding boxes over them. So you're going to see someone walk across. And you see the green and red, that is doing bounding box calculations. It's figuring out where people are.
Tu t'arrêtes quand je te le dis. Stop.
I just think that's amazing. So as someone moves, it's doing motion tracking. And of course, it can stay responsive as the video comes through by using web workers. All right, so now that you've seen these being used, let's actually look at using web workers in your code. So the first thing is you have to put all of your workers into a separate file, and you instantiate a new worker like this. The thing to know about workers is they need to be siloed from the rest of your JavaScript because they will run in a different context. They can't access the screen, so they can just do work. They actually can do XML HTTP request calls. They can access the database, and you actually pass data back and forth for them to work with, and they hand you the data back. And the way you do that is you set onMessage events. So over on the browser side, you say worker.onMessage, and you give a function that will get called when the worker talks back to you. And here we are grabbing the event and outputting the data. You could imagine taking that data, such as from that video tracking, and that data may be, here are the coordinates of where the person is, and you could and then use the canvas tag to draw on the video. Over on the worker side, you just provide JavaScript. Here we are, we have a find primes method. We would plug a prime number algorithm in here. Once we found a prime number, we're going to send a message over to the JavaScript side. And post message is a magic method that allows you to send something over to the browser. So it's really straightforward. You just sort of toss these events back and forth. And this one is well supported as well. On Opera, it's only on the mobile edition, but web workers are already across Chrome, Firefox, and Safari. So that brings us to the end of our training today. This is really just the start. Like I said, HTML5 has all sorts of interesting things. You got a taste of that with seeing some of the markup of the YouTube prototype. And so I encourage you to begin working with these things, create really cool demos and sites, and thank you so much for your time.